Hello, welcome to another Blender Sushi live noding video tutorial. Um, Again, today I'll be exploring animation nodes, and today's topic is about how to make procedural explode kind of effects. I believe in Houdini, another 3D package, you have there's a node called Explode SOP for surface operator. What it does is basically if you have like a bunch of objects in the scene like that, and the explode modifiers allow you to kind of separate, kind of push all the objects outside like that. It's useful when you have like a even like an OBJ, that you have the OBJ itself can be like a separate part like this, and then if you use that node, you just plug in into the node, and then the node will push the objects outside like this based on a single points. I thought that might be something that's useful to create in animation nodes. It's actually really simple, but you might learn a couple of concepts as well. And let's see. Okay, just one more thing. Like at the moment, all these objects are separate, but you might have like an OBJ that comes like, if I press Command J, Control J, the OBJ might be a joined object like this, and we must need to consider. We might need to separate the by loose part, so it's become a separate parts again, and then we might need to reset. What's the shortcut? Command Shift C, Command Option. Yeah, I don't know the shortcut because I'm using Mac keyboard. Basically, there is a shortcut to ensure the origin is back at the center of the object before you do anything, before you push the objects out. That's something to keep in mind, and I'll just delete the grease pencil, delete all these objects. If you're doing it, if you probably you know the term explode modifier, and you might think of, okay, I know that Blender has explode modifier right there. You might know that node and you might have used it. If you haven't used it, it's actually useful if you have a single objects like that or bunch of objects. But in order for it to work, you need to use particles. There's a couple of ways to do that actually. Let's say if you have a torus, for example, and you hit space and then explode, I believe explode, there's a quick explode. What it does is it creates a particle system for these particle objects, and then apply the explode modifier directly after the particle system is created. So you have something like that. It separated the faces automatically for you because the setting of the particle right there, and it has the gravity option as well already set, so it's kind of forced out and then fall down. If you turn off the gravity, it will just probably it's being pushed all over the place. That's kind of the effect we want to do today, even though we're probably not gonna be separating each faces like that. We just kind of push the objects itself, not the face or parts of the objects. It's a good start, I guess, because yeah, you will understand what I'm saying. I'm talking about later on. So let's just create a new startup files. We have this guy. Let's hide the camera and the lamp. So I will just create some bunch of objects in the scene. It can be anything. Monkey head, maybe icosphere. Maybe I'll just create a cylinder. So we have these 5 objects, and then we just want to push it out based on one single point, maybe an empty or locator like that. So we want to set up animation nodes that enable us to push all these objects, just like exploding kind of effects. So let's do that. File, save as animation node, explode modifier 01. Let's go to compositing. I'll show you the wrong way. I mean, this is my first try to do it, and then I didn't know one important information, and then I asked at the Blender Stack Exchange for animation nodes topic, and then Jax kind of give me the clue on how we can do it. I'll show you the wrong way we do it first. So I have bunch of objects, right? In order to bring it in, like in previous video tutorial, we need to group it first. Control G, so they're grouped and they're all the same color of green, and the group name is group, like that. So I will switch to animation nodes, node 3, create a new node 3. Let's create objects. Once again, objects from group node. So, and pick up our group, and of course group comes in the input, and the output is objects, like list of objects, and we want to loop over it. So I will tap on W, and we're gonna loop through each object, and what we want is just to push all the objects out in reference to that single points. So we're gonna bring in this, we're gonna reference the single points position first. So object transform input, and this guy will just bring in the position of that empty. We only need the location, so we create a new parameter. We're not gonna iterate over that single object. It's gonna be the same single objects for all, so we just use the parameter. It's gonna be a vector location. See, the color is blue. It's the same type of data. Okay, we have the each and every objects being iterated, and our vector reference. And if you watch the previous video and I talk about vector, how we can aim bunch of eyes into a single point, this time we want to kind of push all these objects out in all directions from that single point. So you can use the same math. It's just a simple vector subtraction, I believe. So we have our objects, and then we will need to have their position. So let's transform input. Yeah, get our objects. This is actually the wrong way to do it. I think what will happen is the objects will fly and disappear, because there's like kind of like a cycle loop that Blender doesn't like, or it's something you shouldn't do. But anyway, let's just have a look. Plug that in, subtract. Let's debug. debug a little bit. Let's see what's the data output. It's gonna be click, click. Alright, we have some vectors that we can use as directions. And then you might think, okay, I'm gonna create object transform output, of course, and plug in our objects, and then location will be that. Okay, as you can see, all our objects flies away into 3D space and they're just gonna disappear. It's the wrong way to do it. It's not gonna work. So I'm just gonna disconnect this. Now all the objects goes back to 0. It's kind of like similar to the case where you have the object mesh data input and then you do something with the data and you plug it in back into the object mesh data and then it will explode, or it just doesn't know what to do. What you need to do back then with the object mesh data, you create like a copy, like kind of like the default, like a ghost copy of the original objects, so it knows where to start with, kind of like a default position. And you can do that using animation node. There is a kind of like a secret feature. So I put all the objects in position again, like that. We need to tell animation nodes what is the initial transform for each object. So that's really important. You need to select each and every object. So if you have, we only have 5 objects in the scene right now, but if you have like 100 objects, it's kind of silly to click one by one like this. So if the objects are already grouped, we can Shift G in Blender and then select grouped. So that's one way to do it. Okay, the secret animation nodes menu is hidden in here. I believe it's AN. There's an animation node. It's actually kind of hidden right there. My laptop screen is small, so it can't really see it, but it's actually supposed to read AN, animation nodes. So this is the secret animation node menu. This is a special menu that tells animation nodes kind of like object hidden attribute that tells animation nodes to store the initial transform for each object. It's not a per point space, but for each object we can store the current transform. So this is going to be the initial transform. All we need to do is select each object again and click on this button. And now we have the initial transforms data per object stored in the animation nodes memory. So let's save this, and then now we can use that information inside here. So instead of plugging this guy in and then tell it to start from 0, 0, 0 and push it out, that's kind of confusing. It's giving a cycle. We will not be using object transform inputs. We will be using something called object ID key, and this is really cool. We just need to plug in our object in and then choose the ID key, which is, there are others, but I think initial transform is the only one. Yeah, initial transform, just like that. Super simple. So it's keeping, so it's kind of like a side memory. It knows each objects now know and remember their initial positions. We just need to pipe the data in, similar to before, there's a location rotation scale that we can also plug in here if we wanted to use the initial rotations. For now we just be dealing with the location, so location, and we have this vector mass subtract. It's gonna give us the normal kind of, it's gonna give us the direction, vector direction of where we want these objects to fly away. So let's create a vector. It's a vector normal vectors, another vector math. We're just gonna add result. Maybe we can use scale. Let's have a look. So we plug in the objects, original objects, and then like that, and we can now just push our objects just like that. It's really simple. It's a but it's also useful. So we have like kind of explode effects, and since we have this guy as a reference, we can kind of tell it, okay, you should explode like that. Or normally you wanted to explode from the center, like a center mesh of all the grouped objects. There must be a way to get that center object. So at those moment we have just like 5 objects. Let's say I have more. Yeah, and so I cannot just duplicate it. I need to cut it. Yeah, this is one of the things you need to be careful. You need to set the initial transform. If you create another object, you need to set initial transform, and then you need to also put it in the same group. So now now it's free. I disconnect the node up there, so animation node is not controlling the objects. I just create a bunch more objects like that, and they are already in the same group, but I need to again to initialize the transform. A little bit like working with particle, but it directly works with objects, and this is all procedural. So make sure I do that correctly. We have initial transform, blah blah blah. Okay, objects goes in. Maybe we plug this in before the object, so you're not surprised that all the objects goes back to 0 0 0. Objects goes in. It's kind of moved slightly, but interesting. But anyway, that's how you create explode modifier. But I will give you more demo, like in addition to push the objects, we might want to, let's say we might want to perhaps rotate them as well. Rotate, so it rotate. Of course we want to use the initial rotations, and with vector math, rotation is different. It's actually, see, it's darker color blue. It's a Euler, so we need to use a Euler math. Euler math is gonna be adding from the initial position. We're gonna add it's a wiggle, or no, it's actually gonna be using, do we have random Euler? We do. Random Euler, plug in random Euler with the seed at 0. Let's see what happens if we plug that in. Okay, now, yeah, so the objects are rotating the same. If we plug in the index into the seed, now each object will fly away. Scale at scale 0 they're back to original position, and then it rotates. Let's see, with vector we have vector mass scale here. You might want to, if you want things to start from 0 like that, maybe another vector math will do it. Just duplicate that and just plug that in. Scale add, scale add, so add. Interesting. Maybe that's not how we do it. We should probably this should be let's subtract. So that's our normal. We should have add at some point. Add. So that's the original position, and this is our normal. And then we have this. Maybe we multiply. Maybe we plug that in there like that. So we have, okay, that's 0. That's 1. Maybe, okay, this is the normal. Maybe we need a like a normalize or something. Normalize vector, yeah. It's always good to normalize the vector. So, and then we can have 0 right there. Okay, then we can use that scale. Okay, got it. Normalize the vector normal, basically making sure that each normal is at their 0 strength or length, I believe. So now each objects are correctly back in their position, and we have this 0 number we can use. So supposedly we can have a new parameter and call it float, and just call it explode, and now user can use this number to control the explode factor. Explode like that. So yeah, that's basically it. You can further enhance this setup by using like a BVH, and with the BVH you have control over, let's say you have a cube, and this cube is gonna be kind of like an area where you can influence objects where it should explode. You use BVH for that. KD3 might work as well. Anyhow, this is Explode Modifier, similar to Houdini owns Explode Modifier, that you can use this for other stuff. Maybe can we work on a text, or let me add, or we okay, maybe we can use the Blender cell fracture, kind of like the Voronoi fracture that Blender has. I'm gonna delete all these objects. Okay, Shift G and select all and delete, so we don't have our explode objects anymore. I'm just gonna save this and save it again, just in case. Okay, and so let's go to user preferences. There is this hidden add-on called cell fracture. There are some bunch of really useful add-on that comes with Blender. You don't need to install it if you don't want, but if you need it, you can install it. This cell fracture. So Blender doesn't have the built-in fracture modifier yet at this moment, but we can use this add-on called cell fracture and close this. So if you have a mesh object, let's see, perhaps a torus will work. Yeah, torus, I like torus, and Alt G will put the torus in the center. Gonna expand the torus. Okay, we have our torus right there, and we're gonna use the cell fracture to kind of Voronoi. It's gonna cut all this torus into separate objects using Voronoi kind of functions. So I'm selecting the objects. All we need to do is space and then cell, type cell fracture selected mesh objects. Usually when you're exploding objects, you need to fracture it first in 3D, so kind of like a cheat, but you do that all the time. Source limit, how many? I'll leave it at the default. You can also draw some grease pencils or create particles and set it up, but we keep it simple. Just leave it as it is and then let it cut. Okay, let's see whether this works. Hopefully it doesn't crash. It's doing something in the background. Let's just wait. Maybe this number is too big. Okay, it's finished. It's like, yeah, the first time you use this add-on, you will question, hey, what's actually happened? These objects stay like that. There's nothing happens. It's actually fracture these objects and then save it into second layer. And then in the second layer, I have this light and camera. I just put it on the third layer. If I select these objects, it's actually like a fractured object. So that's cool. I'll save this real quick. So you have the original object right there, and you have the fractured object, which is this guy right here. Yeah. Now we can work on these objects. Let's see. Their pivot is already correct. All we need to do is just select all of them. You can press B and then select objects like that. Sometimes in Blender, if you select objects and then you can't do something that you think you can, you need to shift click just a single object so it knows this is the thingy that we want to work on. Yes, let's say you are actually, if you tap on A, it selects all objects in this layer and you can't do thing, just shift and click on any objects and then now you can group it. Control G. I'm grouping all these fractures objects, and then before I forget, while these objects are still selected, we need to create the initial transform. Remember to do this, otherwise it's not gonna work as you want. The group name, if we check, this is group.001, so let's do that. Okay, this Is it working? Let's zero out the explode. It's back to normal. If we push it out, it's exploding out. And this is all procedural. Procedural is cool because it's not a simulation. You have total control on everything. Basically every single object transform, rotation, position, and scaling as well. You have control over the scaling. You can make the objects scale down, perhaps, as each explode out. That could be interesting idea to try. Should we do that? 0 to 1 scale. Let me think. 0 to 1, we need to kind of reverse the number. Okay, let's try. First of all, it's 3 numbers, so we can use float to vector from value. So we have that single value. If we just use the explode value, it's gonna grow instead of becoming smaller and smaller. So it's the opposite. So we need to use math. I believe it's math, number. Sometimes I cheat and use map range. So if they start from 0 to 1 and we want to go from 1 to 0, that's a quick cheat. I'm not sure if it's slow. Maybe it's not slow. Perhaps we can change the number here from, instead of 0 to 1, maybe from 0 to 10. So from 0 to 10, it will slowly become smaller and smaller and disappear like that. Maybe we can start at 5. So from 0 to 5 it will, but from 5 to 10 start to disappear. So that's one way to approach it, I guess. You can even use interpolations, but yes. So that's exploding. That's how you create exploding type of effects using animation nodes. Very useful. Of course, we wish we have like a fracture, like a Voronoi fracture node inside animation nodes or Sphere or from Blender's own modifier. We're definitely gonna get Voronoi fracture in here, I'm pretty sure, and by then we can do this more procedurally. So with a self fracture add-on, so it's only does it once, and then you can't change any parameter after you do it. But if it's a modifier, you can change it and tweak it anytime you like. So we have this kind of effects. And I think that's it, except if you're okay. Well, maybe I'll show you one more trick. So whenever you're fracturing objects, like I told you, we're gonna have the original objects, right? And then in CG, in computer graphics, we we fracture the objects. We fracture the original objects first, and then scatter all of them, scatter each part separately. So we already break the objects and then replace the objects. So if you're using this effect and then you're just using if you're using just the fracture objects and then you're thinking, okay, 0 they explode, you actually sometimes you can still see the crack already, and that's kind of defeat the purpose. Kind of people will say, hey, that object is already shattered or scattered or cracked or fractured before it fractures. So you don't want that. We want to hide the crack, and normally you'd key the visibility. So you have these objects first, the original objects, no crack, and you key animate the visibility so it switch to the fractured objects under one frame, so you can't tell, so the audience cannot tell. But since we are using animation nodes, I'll show you a simple trick. So you have these objects, and let's see, object visibility. I'll display both layer 1 and layer 2. We have the original objects and the fractured objects. We can control the visibility using animation nodes, luckily. So there's a visibility input and output. Visibility output. Normally, I believe you're animating the visibility, you need to go into outliner and use keyframe the visibility here, or maybe here as well. They don't have it displayed. No, cannot keyframe the visibility here. Cannot close that. We can hide objects like that. So this is the default torus and all the fracture cell. Keyframing this will be a pain in the ass. So there's this object visibility output and object visibility input that you can use. Let me duplicate this. I know I did this once. Let me try to do it live. Objects visibility output. Basically, it's very simple. So we have, this is the default torus. If we use the object visibility output, we grab the object and then we toggle, turn on the hide, and then we can turn on and off. We can also hide it in the render. So if we turn on this option, look at here and see it's toggling, and you can kind of, you're not keyframing anything in animation nodes. Actually you can, but normally you use another value to do this kind of toggle. So now we know we can hide stuff, and so to hide a bunch of objects we can also do the same. Just pipe that in, turn on the hide, on and off. So we have on and off control for, let's just put it right there and plug that in here. Okay, we have on and off control. Let's create a new parameter. Let's call it, it's gonna be a boolean, because it's a switch on and off. It's gonna be a boolean, so it's gonna be visibility. Now I can control. So this is our setup, our really super simple setup right here. At this time you can hide it, like press H to hide everything, hide it, put it somewhere else. We still have our exploding effect, procedural explode happening, and now we have the visibility control. That's not working because we haven't plugged it in. Visibility goes into that thing. Okay, visibility and explode visibility. Normally it's okay, you might, if it's thick it should be visible, so we want kind of reverse, kind of invert the boolean. There's a boolean, invert boolean node. We can just put it there. So on, off, on, off. Okay, you have that. You have the empty as reference. You have this group. Let's save this. And what I really want to show you is you can use like a combo of this node. Let's turn this on. With everything. We can use a like a clever kind of expression node, and then we can use frame number. Plug this in. X will be the time. If the time is bigger than, let's say 10, let's see, the result should be your boolean. I think it should be clever enough to do that. So you see what happened if we create a debug, to see the output. So with expression, it's a kind of like a logic operator. There's also all kind of different logic here. Boolean, invert, compare, switch logic, list logic. They're they're super useful. And let's see, logic operators. This is also super useful nodes if you are doing a lot of logic operations. With logic operations and switch, basically you can potentially create kind of simulation or solvers. So you can tell an object to move left if blah blah blah, or turn right if blah blah blah, or keep going straight with switch and logic. That's gonna be a little bit more complicated, maybe for another video. For now, let's just we don't need this. Just kill it. So we have time and we have this expression node. Basically what I'm doing here, we are telling Blender and animation nodes. So if the time is bigger than 10, it's true, right? The logics become true. That means it's gonna be hidden. So this is, so after frame 10, it's gonna be hidden. But we probably want it to be 0. So if it's a 0, at frame 0 our object is showing. At frame 1 it's gonna disappear. That's what we want. But when this original object disappears, we want the fracture to appear, and it's kind of the opposite. If our original object is still displaying, our fracture should be off. So we can just plug that in and use this, plug this into there. So if all well as planned, we have that effect happening now. So frame 0, our original objects. Frame 1, our fractured object, and of course our object will explode. So, and then we can simply plug in the frame into the explode. I'm just gonna save this. So back to frame 0. Frame 0, Blender used to start from frame 0, but now they start from frame 1, so we can change this to frame 1. At frame 1, our object is displaying, but after that it's gonna crack and explode. That's probably too fast, so we might want to use math. And reduce the speed, so by maybe 0.05 frame 1, and then crack. It's just explode like that. Maybe 0.002. Our time is actually a floating number, so we can say things like 1.5. It's pretty accurate. So before and crack, 0.1. You can actually tell it like this as well. If frame is exactly at frame 1, and then if it's not at frame 1, crack. But be careful with that, because you might be like, if you're at frame 0, it's you're better off doing it like this, 0.1 like that. So at frame 1, maybe 1.5. Let's see. Yep, wrong type of operator. Okay, 1, 0, 1, and then crack. 0, 1, and crack, and then slowly it will disappear like that. So if I just maximize this, we have control over this guy. Maybe it's gonna explode up. And if you play back, let's try that. Play back. It's gonna slowly exploding and disappearing. Probably now it takes super long time to explode, because our explode is controlled by time. But I guess that's kind of like a slowly exploding planets, kind of like planet Earth and the universe. Anyway, that's so that's a procedural explode, and I'm showing you pretty much everything that kind of related to explode. So it's, as you can see, it's really fast, and you can scrub in the timeline. That's actually how procedural setup should be. And user have control over all this. Let's see, back to node editor. You can still tweak the setup, maybe make the rotations a little bit faster, maybe you want to make the scale a little bit faster as well. All kind of things you can do with the setup. And then back to, maybe you want to change the torus. Instead of torus, you want to like the monkey head, or maybe letter. So yeah, hopefully that's useful for you. I'll see you in the next live noding video. If you like this video, please subscribe and place comments as well if you have questions and feedbacks. All right, thank you. See you.